Sn here is given the sum of the terms, and we need to evaluate this expression. Summation n starts from 4 to infinity 2 times Sn upon n factorial minus 1 upon n minus 2 factorial. Here Sn is given in terms of expression, and we need to firstly evaluate the Sn. I would write the general term for this. So Sn is nothing but is equal to summation of r into n minus r, because in each term n is same, the value of 1, 2, 3 changes. So r into n minus r starts from 1 to n minus 1. In the next step, Sn is equal to r multiplies inside the bracket, so r into n is n into summation of r starts from 1 to n minus 1 minus r into r is r square, summation of r star from 1 to n minus 1. Since we know that summation of n starts from 1 to n is 1 plus 2 plus 3 plus so on up to n, and its formula is n into n plus 1 by 2, and summation of n square n starts from 1 to n is equal to 1 square plus 2 square plus 3 square so on up to n square is equal to n into n plus 1 into 2n plus 1 by 6. Applying these two formulas here and here, we get Sn is equal to n times n minus 1 into n minus 1 plus 1 by 2 minus n minus 1 into n minus 1 plus 1 into 2 into n minus 1 plus 1 whole divided by 6. So Sn becomes n square into n minus 1 upon 2. Here minus 1 plus 1 cancel, minus n into n minus 1 into 2n minus 1 by 6. Taking common, I can take n into n minus 1 upon 6 common, so I get 3n minus 2n minus 1 here. On further solving, Sn is equal to n into n minus 1 into n plus 1 upon 6. This is the value of Sn. Now we want to find the value of this expression, so I can write it as becomes 2 into it becomes n into n minus 1 into n plus 1. 2 by 6 becomes 3 here, and n factorial is nothing but n into n minus 1 into n minus 2 factorial minus 1 upon n minus 2 factorial. N cancels, n minus 1 cancels. The solving, we get summation n starts from 4 to infinity n plus 1 minus 3 upon 3 into n minus 2 factorial to 1 upon 3 summation n starts from 4 to infinity 1 upon n minus 3 factorial. We get 1 upon 3. On putting 4, I get 1 upon 1 factorial. On putting 5, we get 1 upon 2 factorial. On putting 6, I get 1 upon 3 factorial, and up to infinity. Since we know that e raised to power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x to the power 4 by 4 factorial plus so on up to infinity. E is equal to 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus so on up to infinity. This term from here to here, we can see this pattern here. So this one can be taken to the left hand side, so it becomes e minus 1 is equal to 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus so on up to infinity. So finally this whole expression becomes 1 upon 3 into e minus 1.